Between the tropics and the cold polar seas lie the most productive habitats in our oceans, temperate seas. The combination of winter storms and long days of summer sunlight creates the perfect environment for life to thrive. Around Ireland's coast, we find a great diversity of life, from tiny, colourful creatures to giants of the ocean. It's in the brightly lit shallows, however, where the greatest diversity of creatures can be found. From winter storms to summer sunshine, endurance and ingenuity are required to survive the extremes of life in the shallows. Ireland's position in the northern latitudes brings our very seasonal weather. And seasonal change is what makes temperate seas so fertile. The energy and turbulence of winter storms churns up nutrients from the seabed and mixes the ocean waters. By early summer, the addition of almost 18 hours of daylight creates a magnificent growth of life in the shallow waters off our coast. It all begins with plankton, from the Greek word planktos, meaning drifter. Plankton is a collection of tiny plants and animals drifting in the current. Many fish and shellfish larvae live within plankton before growing into fully sized adults, while other microscopic creatures and plants live within plankton all their lives. Collectively, they provide the foundation of the ocean food chain.
Plankton basically is floating life. Tiny little animals and plants. There are two different types. Those that live all their lives in the plankton and drift where the winds and water carries them, but also most fixed or bottom-dwelling animals and seaweeds have a problem. They have to colonize new ground, and the way they do this is their eggs or their larval stages live in the plankton, and then when they mature, they drop out of the plankton and live on the bottom. For example, lobsters, large bottom-living creature, starts off its life swimming in plankton. So that's the other huge purpose of the plankton, to allow the creatures of the bottom to colonize new ground, to drift. Once the plankton was discovered, it was realized this was a huge food source. Everything from mussels, indeed up to whales, make a living by filtering the plankton. What happens to these animals afterwards? What happens to a fish when he dies? Partly decays and bacteria go to work in him, partly eaten by crabs, and these produce waste matter, nitrogens, phosphates. That's what the plankton lives on. So in the sea, just as you have on land, you've got this extraordinary cycle where all the parts depend one on another. You don't exist as an individual, you exist as part of something greater.
The shallow waters around Ireland's dramatic coastline hold the greatest concentration of plankton in our seas, providing for a myriad of creatures, creating a diverse and fertile food chain. It's late winter off Ireland's western seaboard, and life in the ocean is thriving with the added sunlight of lengthening days. In the natural world, food and reproduction are every life form's purpose. Eat or be eaten. Camouflage is crucial. If your predators can't see you, they can't eat you. Unless you possess armory that allows you to be exuberant about who you are. Jewel anemones glisten in the sunlight as they prey on small passing creatures, which they stun with the paralyzing toxins in their tentacles. There are dozens of species of anemones found in the shallows, where the constant water movement brings an abundant food supply. Beadlet anemones display a myriad of colors. Although in nature, alluring colors are generally a warning for other creatures. But there is one creature even more flamboyant than the anemone, the nudibranch. They neither hide nor camouflage themselves, and anemones are some of their favorite foods. Nudibranchs display a wonderful example of evolutionary adaptation. Not only are they immune to the anemone's toxins, they actually steal and store these toxins within their tentacles for reuse against their own prey. Swirling in the passing current are hydroids, members of the jellyfish family. Nudibranchs take advantage of the hydroid's immobility. They simply climb down the animal's stalk and eat it. Adding insult to injury, or in this case death, the nudibranchs then lay their own eggs on the hydroid's remains. Hydroids would have died out long ago had they not adapted to this world. They had already spawned their young, who are now at an intermediary stage of life as free-swimming jellies. They'll eventually settle and colonize rock faces as adults. Irish waters are home to some half-dozen species of jellyfish, with moon jellies being the most common. Recent years have seen a big increase in all jellyfish numbers, which scientists attribute to the decline of their main predators, tuna and sea turtles. They feed on plankton and other tiny creatures, which they paralyze with their stinging tentacles. But these tiny fish are unaffected by the blue jelly's sting. They have a mutual arrangement, cleaning the animal in return for food and protection. Moon jellyfish spend the winter as polyps on the seafloor. By early summer, the polyps multiply by dividing themselves into new separate creatures, before developing into fully formed adults. High summer off the Kerry coast, and moon jellyfish have gathered here in their thousands with only one thing in mind. Females are carrying thousands of orange eggs. Males release their sperm into the water. By pulsating over it, the females absorb the sperm through their mouths. Once fertilized, the females release their larvae into the plankton. There they remain until they drop to the seafloor to develop into polyps and begin their cycle of life once again. In the deep ocean, seawater settles into layers according to temperature. Surface waters are warmed by the heat of the sun, but below a depth of 100 meters, water suddenly becomes colder. In the shallows, however, winter storms churn up cold, nutrient-rich water from the seabed, mixing it with warmer surface water. Waves breaking on the shallow reefs make the water oxygen-rich. Longer days bring extra sunlight to the shallows, and life begins to thrive. Immobile creatures such as urchins, barnacles, and mussels are well adapted to surviving these conditions. Though they have sharp spines, purple urchins protect themselves further from predators by boring into soft limestone. Over-harvested in the past, they are now almost extinct around the Irish coast. Barnacles thrive here with up to 10,000 animals in a square meter. And a single barnacle can produce up to 20,000 larvae each year. They feed by extending their limbs to grab passing food. And although tiny, barnacles can boast the largest penis-to-body ratio in the animal kingdom, allowing them to mate with their neighbors. During low tide, barnacles must survive the desiccation of hours of sunlight. With such enormous numbers, living space is at a premium, and they must compete with mussels for rock space. The passing debris is a boon for the filter-feeding mussels who also thrive here in the shallows. But where creatures thrive, so also do their predators. Dog whelks prey on mussels and barnacles. Drilling a tiny hole in the mussel shell, they insert a paralyzing acid. As the creature dies, its shell opens and the whelk feasts on the mussel within. Nothing in the sea is ever wasted. This hermit crab has moved into an empty whelk shell and is now feeding on the mussel scraps. Meanwhile, flat-top shells graze on the algae of whelk and crab shells. Well-nourished, the creature knows instinctively to release its eggs into the passing current, where they become part of plankton. Many of these eggs will be eaten by other creatures. Unlike the flat-top shells, dog whelks bear their young in egg cases, which they glue onto rock faces. In the 1970s, dog whelk numbers were decimated by the use of TBT, a chemical used to stop algae growing on boat hulls. Because their eggs are localized and don't drift to new areas within plankton, dog whelk numbers never recovered in many places around the coast. Over many thousands of years, a natural balance has been achieved within our ocean waters. As creatures and plants die away, they provide nutrients for new generations of life. While Irish coastal waters are largely pollution-free, some recent practices on land are putting pressure on the delicate balance of our marine ecosystem. Water quality on land is not only important for people, but also for marine life, as every drop of water in every river in Ireland ends up in the sea.
Transfers of nitrogen and phosphates from land to sea are very common, and so it has been for 3,000 million years. What's new in all of this is that in the last 150 years, people have understood how to convert atmospheric nitrogen into nitrogen fertilizer. And that's very powerful stuff added to any ecosystem, land or sea. So not alone have you the natural cycles, which have always run, they're now being supercharged. And supercharged possibly to the point where the nitrogen we don't use to produce our own food, but which we produce and goes to waste, is now getting into the ocean, into lakes and rivers, onto land, and everywhere it goes, it turns the ecosystems inside out. In some farming practice, anything up to 60–70% of the nitrogen put on the land never goes near the food chain. It just gets into the soil and sluices out. Wherever you see a large amount of green algae, there's at least a question mark. Is this due to excess nitrogen?
The past century has seen much change in our shallow waters. What we see now would have been unrecognizable 100 years ago. Sargassum is a highly invasive alien species of seaweed, usually found in Japan. It was first seen in Ireland in 2001. Like many alien species found in our waters, it's believed it was transported here within ship ballast. This weed has an aggressive effect on the marine environment. Growing up to 10 centimeters a day, it can reach a height of 16 meters in certain areas. Spreading across the surface water, sargassum eventually blocks sunlight from reaching the seabed, all of which has an adverse effect on the ecosystem. Native seaweeds thrive in our coastal waters, providing food and shelter for many creatures. Because they need light to survive, seaweeds are generally found in the relatively shallow parts of our seas. Seaweeds are plants, absorbing nutrients from the surrounding water. Almost 500 different types of seaweeds are found around the Irish coast, from the large kelps that form vast forests, to smaller weeds which carpet the seabed. Seaweeds are vital as a habitat for all sorts of marine organisms. The myriad small animals that feed on seaweeds are in turn eaten by larger animals and so on up through the food chain. Stretching for almost 6,000 kilometres, Ireland's meandering coast holds a variety of habitats for marine life. Just as on land, much of life in the sea begins on the ground, underwater, that being the seabed. There are many kinds of seabed habitats in Irish waters. From clear, sandy bottoms to the myriad of sea grasses and seaweeds, along with rocky bottoms and crevices. In each environment, life has evolved differently, but always in ways that make use of the habitat for camouflage, shelter, and ultimately, survival. Sand is the most common seabed habitat in the shallow seas around Ireland. Although at first glance, it may not appear to hold much life. Many thousands of creatures have adapted to using sand for shelter and camouflage. As sand shifts with the tide off the Mayo coast, this large place remains very still, waiting for prey to arrive. Thornback rays, however, actively patrol the shallow sands for food. They're well protected against predators, with a line of spiny thorns running the length of their body. They feed on small fish and crustaceans. Shrimp, however, have learned to stay out of their way. Being at the top of the food chain, stingrays are not quite so concerned with camouflage. They have adapted wonderfully to living on sandy bottoms. Using their wings, they stir up sand, unearthing the hidden creatures. And unlike many other fish, a stingray's mouth is under its body, closer to its prey. Ireland's position in the high latitudes brings up to 18 hours of daylight during midsummer. The energy from this sunlight combines with all the fertile organisms in our seas to provide the perfect habitat for seaweeds to thrive. And seaweeds provide a basis for life in the ocean. There are dozens of species of small crabs in our waters. They thrive here on the abundance of life in the weedy shallows. While species vary greatly in appearance, they all adopt wonderful camouflage techniques. Shore crabs hide by displaying a pigmentation which exactly matches their background. Spider crabs use seaweeds to disguise themselves. Their spiny shells have adapted perfectly to allow weeds to grow on them. In early summer, they migrate into the shallow waters around the Mare Islands off West Kerry to breed. Mating rituals last for several weeks. After fertilization, the female's several thousand eggs will eventually fall onto the seafloor and develop within the weedy habitat. With their solid blue armory, and being the largest crustacean in Irish waters, lobsters, however, never seem to worry much about camouflaging themselves from predators. That is, until man arrived. Lobster numbers have declined hugely in many parts of Ireland, and as a result, one of their favourite prey, white urchins, have abounded. Grazing at the base of kelp, these urchins can kill a full plant by eating just the roots. Their increased numbers have resulted in the destruction of kelp forests in many areas. Building their nests among red and green seaweeds, cork-wing wrasse vary their colours to match the surroundings. In the mating season, however, males break cover with even more vibrant colours to attract a female. The males aggressively guard their nests in the shallow weeds. Balan wrasse, however, favour rocky bottoms. The largest of the wrasse family, they feed by crushing sand between their two rows of powerful teeth, separating out tiny crustaceans from the hard sand. In the rocky shallows of the Clare coast, chamois seem more inclined to creep around on their front feet than to swim. They feed well on the rock surfaces which are carpeted with their favourite food, acorn barnacles. It's springtime in the fertile waters of Galway Bay, and sea hares have migrated into the shallows. Feeding on seaweed, they absorb its chlorophyll, displaying it in their outer skin, a natural camouflage. The chlorophyll also continues to photosynthesize sunlight into carbohydrates, which actually feeds the animal. These sea hares, though, have come here primarily to mate. They're hermaphrodites, possessing both male and female reproductive organs. While mating, they form love chains of up to 20 animals, the front of the creature being male and the rear female. With all of this good intent, many egg masses are spawned. Despite their name, sea hares are slow movers. But they have one other exceptional ability. They can fly. The folds of tissue across their back open out into wings, allowing them to glide through the water. This mobility allows the hares to cover greater distances in shorter periods of time, enabling them to discover and settle in new habitats. Storms can have massive impact within the sea. Moving sands and sculpting new surfaces underwater. This has a direct effect on the life which lives within this habitat. Coastal turbulence can break down proteins, such as those within plankton, creating swathes of foam along the seashore. Goose barnacles live on flotsam, such as tree trunks floating in the sea. This mobility brings them to an abundant food supply. The log which these creatures call home has been shipwrecked in a winter storm. While they may survive for many days out of water, they will eventually wither away and die unless returned to the sea. Along the Clare coast, sand eels have blossomed on spring plankton. Their numbers have peaked and they are now ready to breed. Sand eels are a vital part of the marine ecosystem, being a staple food for many larger creatures. Their gathering, however, has not gone unnoticed by pollock, one of the most common fish in the shallows. Cleverly working together, pollock corral the eels into tight groups, making them easier to catch. Underwater, grey seals are masters of their habitat. They bide their time, lying in wait for pollock. Meanwhile, on the sandy beach of Great Blasket Island off the West Kerry coast, a colony of over 150 grey seals arrive in late autumn to breed and bear their young. Seals are the largest animals on our coast, capable of using both land and sea. And with few natural predators, these seals can rest easy as they spend their time. Mothers spend several weeks nursing their young in the more sheltered coves. And after 3 weeks, the pups are weaned off their mother's milk and left to fend for themselves. On the main beach, the males spend most of their time keeping a close eye on their harem of young females. Once the young pups are strong enough, their mothers join the other females and breed again before they move on. In coastal areas, tides mean that marine habitats are constantly changing and reinventing themselves. On the shore, life has to keep up with this changing environment. Therefore, you find a very versatile array of life in and around the shallow waters of our coast. Living on the sea floor, and even between the tides, hermit crabs scavenge for their food. Although capable of surviving on land for a time, hermit crabs must keep their gills wet in order to survive. They're actually neither hermits nor crabs, but social animals more closely related to lobsters. Born without their own shells, they use the abandoned shells of periwinkles or whelks. Being small, it helps to have friends. The moss-like growth on the crab's borrowed shell is actually a sea anemone. The crab's mobility gives the anemone access to a greater food supply, while the anemone's stinging cells help protect the crab. As the crab outgrows its shell, the anemone will move with it to a new, larger shell, keeping pace with the growth of the crab. Squat lobsters are close relatives of hermit crabs. They live in the rocky crevices of deeper waters where life seems to become more exotic. Nighttime off the Kerry coast. While most land animals are sleeping, the seafloor is coming alive with creatures that have remained hidden during the daylight. Having spent the day buried within sand, this masked crab has emerged to patrol the seafloor for food. Many creatures hunt in the shallow sands under cover of darkness. Although some have the added advantage of camouflage to aid them. Flatfish are masters in the art of camouflage, as they have remarkable abilities when it comes to changing their skin color to match their surroundings. Blending with the sands as they move about, they can also quickly bury themselves to aid in their camouflage. This technique of burying oneself works both for evasion and attack. After several hours of hunting, this masked crab buries itself within the sands for another day. Its antennae remain above the sand, bringing water to its gills so that the creature can breathe. But the master of all for camouflage is surely the little cuttle, sometimes known as sepiola. Their name is the origin of the color sepia, and their ink was traditionally used by artists. Even though they're colorblind, little cuttles can rapidly change their skin color to match any environment. They're even capable of doing this in total darkness. Little cuttles hunt by blowing jets of water into sand, searching for tiny crustaceans, octopuses, and even other cuttlefish. They're amongst the most intelligent of invertebrates, having one of the largest brain-to-body size ratio of all invertebrates. Nighttime is also a good time to meet other little cuttles. When threatened, they squirt a dark ink from their body, which distracts their predators and propels them away from harm. Ultimately, little cuttles, like other creatures here, use their camouflage to create a sanctuary within their habitat. Autumn time off the Kerry coast and moon jellies have reached the end of their life cycle. Now as spent force, their bodies fall to the seafloor. Nothing is ever wasted in the sea, however, and Dahlia anemones nourish themselves for the difficult winter ahead on the fallen creatures. Having spawned their young during maturity, moon jelly larvae will develop into polyps over the winter and in spring reawaken to become next year's adults, continuing the cycle of life.